Okay, so good day and welcome to our virtual class. So chapter 11. So our topic today is about design, prototyping, and construction. It's overview for our lesson. Prototyping, conceptual design, concrete design, using scenarios, generating prototype, and construction. So design activities begin once some requirements have been established. The design emerged iteratively through repeated design, evaluation, redesign cycles involving user. Broadly speaking, there are two types of design, conceptual and concrete. So the former is concerned with developing a conceptual model that capture what the product will do and how it will behave, while the latter is concerned with the details of the design such as menu structure, haptic feedback, physical widgets, and graphics. As design cycles become shorter, the distinction between these two becomes blurred, but they are worth distinguishing because each emphasize a differing set of design concerns. For user to evaluate the design an interactive product effectively, designer must prototype their ideas. So in the early stages of development, these prototypes may be made of paper and cupboards or ready-made components pulled together to allow the evaluation. While as design progress, they become more polished, compact, and robust. So they can resemble the final product. Broadly speaking, the design process may start from two distinct situations. So when starting from scratch or when modifying an existing product. Much of design comes from the later, and it is tempting to think the additional features can be added or existing ones tweaked without the extensive investigation, prototyping, or evaluation. Although prototyping and evaluation activities can be reduced if changes are not significant, they are still valuable and should not be skipped. So prototyping. So what's prototyping? Why prototype? So it is often said that the user can tell you what they want, but when they see something and get used to it, they soon know what they don't want. Having established some requirements, the next step is to try out design ideas through prototyping and evaluation cycle. A prototype is one manifestation of design that allows a stakeholder to interact with it and to explore its suitability. It is limited in that prototype will usually emphasize one set of products characteristic and de-emphasize others. So when you hear the term prototype, you may imagine a scale model of a building or a bridge or a piece of software that crashes every few minutes. A prototype can also be a paper-based outline of a display, a collection of wires and ready-made components, or an electronic features, a video simulation, a complex piece of software and hardware, or a three-dimensional mock-up of a workstation. So the next question is, why prototype? So prototypes are useful when discussing or evaluating ideas with stakeholder. They are communication device among team's member, an effective way to designer to explore design ideas. The activity of building prototypes encourage reflection design, as described and recognized by designer from many disciplines and as important aspect of design. So what is a prototype? Hmm. In fact, a prototype can be anything from a paper-based storyboard through to a complex piece of software, and from a cupboard mock-up to a molded or pressed piece of metal. For example, when the idea for the Fan Pilot was being developed, um, Jeff Hawkins, the founder of the company, carved up a piece of wood about the size and shape of the device he had imagined. He used to carry this piece of wood around with him and pretend to enter information into it, just to see what it would be like to own such a device. So this is an example of a very simple prototype, but it serves its purpose of simulating scenarios of use. So advanced in 3D printer technologies, coupled with reducing price, have increased their use in design. It is now possible to take a 3D model from a software package and print a prototype. Even soft toys and chocolate may be printed in this way. So a teddy bear printed from a warframe. So what is a prototype? Again, interaction design, it can be a series of sketches, a storyboard, like a cartoon-like series of scene, a PowerPoint slideshow, a video simulating the use of system, a lump of wood, like yung sinabi natin kanina, a cardboard mock-up, a piece of software with limited functionality, written in a target language or in another language. So why prototype? Um, Prototype answers question and support designer in choosing between alternatives. Hence, they serve a variety of purposes. For example, to test the technical feasibility of an idea, to clarify some vague requirements, to do some user testing, evaluation, or to check that a certain design direction is compatible with the rest of product development. The purpose of a prototype will influence the kind of prototype that is appropriate to build. Prototype shows the intended function and buttons, their positioning and labeling, and the overall shape of the device. But none of the button actually works. So this kind of prototype is sufficient to investigate scenarios of use and decide, for example, whether the button, image, and labels are appropriate and the function sufficient, but not to test whether the speech is loud enough or response fast enough. Okay, so filtering dimensions, we have the appearance. So appearance, syempre included dyan ng size, color, shape, margins, form, weight, texture, proportion, hardness, transparency, gradation, haptic, and sounds. Then we have the data size, the data type, example, string, media, data use, privacy type, hierarchy, or organization. Then we have the functionality, system function, user functional need. So input behavior, output behavior, feedback behavior, information behavior. Then we have the spatial structure, arrangement of interface or information elements, relationship among interface or information element, which can be either 2 or 3 dimensional, intangible or tangible mix. Excuse. Um, a proposed view of prototypes which focus on their role as filters, like I said, to emphasize specific aspect of a product being explored by prototype and manifestation of design. Example, as a tool to help designer develop their design idea through external representation. So they suggest 3 kinds of principle in their view of the anatomy of prototypes. First is the fundamental prototyping principle. Prototyping is an activity with the purpose of creating manifestation that is in its simplest form. Filters the qualities in which designers are interested without distorting the understanding of the whole. Second is the economic principle of prototyping. The best prototype is one that, in the simplest and the most efficient way, makes the possibilities and limitation of design idea visible and measurable. Third is the anatomy of prototypes. Prototypes are filters that traverse a design space and manifestation of design ideas that concretize and externalize conceptual ideas. mm, Lim, okay, identified several dimensions of filtering and manifestation that may be considered when developing a prototype. Although they point out that these dimensions are not complete but provide a useful starting point for consideration of prototype development. So these are shown in our tables. Okay, so yung table 11 and 11.2. So two common compromises that often must be traded against each other are breadth of functionality provided versus depth. So these two kinds of prototyping are called horizontal prototyping, providing a wide range of function but with little detail, and vertical prototyping. So this one is providing a lot of detail for only a few functions. So other compromises won't be obvious to user of the system. For example, the internal structure of the product may not have been carefully designed, and the prototype may contain spaghetti code or be badly partitioned. One of the dangers of producing a functional prototype is first example natin. Once that user can interact with automatically, is that the prototypes can appear to be the final product. Another is that the developers may consider fewer alternatives because the prototype works and users like it. However, the compromises made in order to produce the prototype must not be ignored, particularly those that are less obvious from the outside. For a good quality product, good engineering principle must be adhered to. Excuse. So what is prototype? So technical issues, workflow task design, screen layout, information display, difficult and controversial critical areas. Okay, so a low fidelity prototyping. Excuse. A low fidelity prototype does not look very much like the final product and does not provide the same functionality. For example, it may use very different materials such as paper and cardboard rather than electronic screen and metal. It may perform only a limited set of functions, or it may only represent the function and not the perform any of them. So the lump of wood, kanina, yung example natin, was used to prototype the fan pilot described. So it is a low fidelity prototype. So a low fidelity prototypes are useful because they tend to be simple, cheap, and quick to produce. This also means that they are simple, cheap, and quick to modify to support exploration of alternative designs and ideas. So this is particularly important in early stage of development during the conceptual design. For example, because prototypes that are used for exploring ideas should be flexible and encourage exploration and modification. Low fidelity prototypes are not meant to be kept and integrated into the final product. They are for exploration only. Okay, so storyboards. Okay, so storyboards often used with scenarios bringing more details. Okay, so storyboarding, okay, is one of the example of a low fidelity prototyping that is often used in conjunction with scenarios, as described in our previous lesson. A storyboard consists of a series of sketches showing how a user might progress through a task using the product under development. It can be a series of screen sketches or a series of scenes showing how a user can perform a task using interactive device. When using conjunction with a scenario, the storyboard provides more details and offers stakeholder a chance to role play with a prototype. So interacting with it by stepping through scenario, this example of storyboard depict a person using a new mobile device for exploration historical site. Yan, example natin. So, sabi kanina, example of a person using a new mobile device for exploration historical site. So, this example show the context of the user, the use for this device, and how it might support Christina. Yan, si Christina, yung actor natin. In her quest for information about the pottery trade at the Acropolis in ancient Greece. Okay, yan, scenarios. No? Next, we have the sketching. Okay. So sketching, low-fidelity prototyping often relies on a hand-drawn sketches. And many people find it difficult to engage in this activity because they are inhibited about the quality of their drawing. Uh, but um, but as Greenberg put it, sketching is not about drawing. Rather, it's about design. So you can get over any inhibition by devising your own symbols and icons and practicing them. Um, Referred to Greenberg as sketching vocabulary, they don't have to be anything more than simple box, stick figures, and stars. So elements you might require in storyboard sketch, for example, include digital device, people, emotion, tables, books, and etc. And actions, such as give and bind, transfer, and write. So if you are sketching an interface design, then you might need to draw various icons, dialog box, and so on. So some simple example are shown in our figure 11.4. Okay, so ito yung example natin ng sketching. So sabi nga daw, hindi naman kailangan na napakaganda ng drawing natin. Then we have the card-based prototype. Prototyping with index card or using index card. So alam naman natin what is index card, di ba? Small piece of a cupboard about 3 by 5 inches. So it's a successful and simple way to prototype an interaction and is used often when developing website. So each card represents a screen or one element of the interaction. In user evaluation, the user can step through the cards pretending to perform the task while interacting with the cards. So next we have the Wizard of Oz. Okay. So the Wizard of Oz is another low-fidelity prototyping method. Sabi nga, it assumes that you have a software-based prototype. So in this technique, the user interacts with the software as thought interacting with the product. So in fact, a human operator simulates the software response to the user. The method takes its name from the classic story of the little girl who is swept away in the storm and finds herself in the lands of Oz. So the Wizard of Oz is a small, shy man who operates a large artificial image of himself from behind a screen where no one can see him. So the Wizard of Oz styles of prototyping has been used successfully for various applications, including the pin trace, a robotic system that helps surgeons to position orthopedic pins accurately during the surgery of hip fracture, and to identify gesture for full body interaction with digital games. Next, we have the high-fidelity prototyping. High-fidelity prototype looks like the final product or provides more functionality than a low-fidelity prototype. For example, a prototype of a software system developed in Visual Basic is higher fidelity than the paper-based markup. A molded piece of plastic with a dummy keyboard is a higher fidelity prototype, of the pan pilot than the lump of wood. High-fidelity prototyping is useful for selling ideas to people and for testing out technical issues. High-fidelity prototypes can be developed by modifying and integrating existing components, both hardware and software. In robotics, this approach has been called tinkering, while in software development, it has been referred to a opportunistic system development. Okay, so reusing existing technology is one of the best way of tinkering. So getting cheap toys or old discarded equipment and hacking them to make them do something new is one of the best way to get a great result. Birds describe how they use this approach to develop a tactile vision sensory substitution system. So a system that translates a camera image of the user environment into a tactile stimulation of their body. Compromises in a prototyping. So by their very nature, prototypes involve compromises. The intention is to produce something quickly to test as an aspect of the product. So Lim suggests an anatomy of prototyping that's a structure, so the different aspect of prototype, what it aims to achieve. So the kind of question that any one prototype can answer is limited, and the prototype must be built with the key issue in mind. So in low fidelity prototyping, it is fairly clear that the compromises have been made. For example, with a paper-based prototype, an obvious compromise is that the device doesn't actually work. For software-based prototyping, some of the compromises will still be fairly clear. For example, the response speed may be slow, or the look and the feel may not be finalized, or only a limited amount of functionality may be available. So the conceptual design. The conceptual design is concerned with transforming requirements into a conceptual model. Designing the conceptual model is fundamental to interaction design, yet the idea of conceptual model can be difficult to grasp. One of the reasons for this is the conceptual model take many different forms and it's not possible to provide a definitive detailed characterization of one. Instead, conceptual design is best understood by exploring and experiencing different approaches to it. And the purpose of this section is to provide you with some concrete suggestion about how to go about doing this. A conceptual model is an outline of what people can do with a product and what concepts are needed to understand how to interact with it. The former will emerge from the current functional requirement. Possibly it will be a subset of them, possibly all of them, and possibly an extended version of them. So the concept needed to understand how to interact with the product depend on the variety of issue related to who the user will be, what kind of interaction will be used, and what kind of interface will be used, terminology, metaphors, application domain, and so on. The first step in getting concrete view of conceptual model is to steep yourself in the data you have gathered uh, about your user and their goals and try to emphasize with them. So from this, a picture of what you want the user experience to be when using the new product will emerge and become more concrete. This process is helped by considering the issue in this section and by using scenarios and prototype to capture and experiment with the idea. Um, Mood boards, traditionally used in fashion and interior design, may be used to capture the desired feel or a new product. So this is informed by the result from the requirements activity and consider in the context of technological feasibility. There are different ways to achieve empathy with user. For example, Bayer and Hosblatt, in their method contextual design, recommends holding review meeting with the team to get different people perspective on the data and what they observe. So this helped to deepen understanding and to expose the whole team to different aspects. Idea will emerge as this extended understanding of the requirements is established, and this can be tested against other data and scenarios. Um, Scenarios discussed with other design team members and prototype for testing with user. So key guiding principle of conceptual designs are keep an open mind but never forget the user and their context. So discuss the idea with other stakeholders as much as possible and use prototyping to get a rapid feedback, then iterate and iterate and iterate. Okay. So is there a suitable metaphor? Interface metaphor combine familiar knowledge with the new knowledge is a way that will help the user understand the product. Choosing a suitable metaphors and combining a new and familiar concept requires a careful balance between utility and fun, and is based on a sound understanding of the user and their context. Uh, for example, consider an educational system to teach a 6-year-old's mathematics. One possible metaphor is a classroom with a teacher standing at a blackboard. But if you consider the user of the system and what is likely to engage them, a metaphor that reminds the children of something they enjoy would be more suitable, such as a ball game, the circus, a playroom, and so on. Erickson suggests a three-step process for choosing a good interface metaphor. So the first step is to understand what the system will do. So example is identifying the functional requirements, developing the partial conceptual model, and trying them out may be part of the process. So the second step is to understand which bits of products are likely to cause user problem. So example, which tasks or subtasks can problems are complicated or are critical. A metaphor is only a partial mapping between the software and the real thing upon which the metaphor is based. So understanding areas in which a user are likely to be have difficulties means that the metaphor can be chosen to support those aspects. And the third step is to generate metaphors. Looking for metaphors in the user description of the task is a good starting point. Also, any metaphor is used in application domain which the user may be familiar, may be suitable. When suitable metaphors have been generated, they need to be evaluated. Uh, Again, Erickson suggests 5 questions to ask. So first natin is how much structure does the metaphor provides? A good metaphor will provide structure and preferably familiar structure. The second question is how much of the metaphor is relevant to the problem? One of the difficulties of using metaphor is that the user may think they understand more than they do and start applying inappropriate elements of the metaphor to the product, leading to the confusion or false expectation. Third is the interface metaphor easy to represent. A good metaphor will be associated with a particular visual and audio elements as well as words. And four, will your audience understand the metaphors? And yung last natin, yung panglima, how extensible is the metaphor? So does it have extra aspect that may have be useful later on? Considering interaction. Okay, so most conceptual models will include a combination of interaction types, and it is necessary to associate to different parts of the interaction with different types. For example, uh, in the travel organizer, one of the user tasks is to find out the visa regularization for a particular destination. Okay, so this will require an instructing approach to interaction as no dialogue is necessary for the system to show the regularization. Excuse. The user simply has to enter a predefined set of information, example, a country, issuing the passport, and destination. On the other hand, trying to identify a vacation for a group or people may be conducted more like a conversation. For example, the user may begin by selecting some characteristic of destination and some time constraint and preferences. Then the organizer will respond with several options and the user will provide more information or preferences and so on. Considering different interfaces at this stage may seem premature, but it has both a design and practical purpose. When thinking about the conceptual model for a product, it's important not to be unduly influenced by the predetermined interface type. Different interface type prompt the support different perspective on the product under the development and suggest different possible behavior. Therefore, considering the effect of different interface on the product at this stage is one of the prompt alternatives. Um, Sample natin again yung organizer natin kanina. So mayroon siyang shareable interface. So the travel organizer has to be shareable as it is intended to be used by a group of people and it should be exciting and fun. The design issue for shareable interface which were introduced in will need to be considered for this system. Okay. So for example, how best whether to use the individual's own device such as smartphone in conjunction with shared interface. Um, then we have the tangible interface. So yung tangible interface are form of sensor-based interaction where blocks or other physical objects are moved around. Thinking about travel organizer, in this way conjures up the interesting image of people collaborating maybe with the physical objects representing themselves traveling. But there are practical problems of having this kind of interface, as the object may be lost or damaged. Augmented and mixed reality, the travel organizer is not the kind of product that's usually designed for an augmented or mixed reality interface. The question is what would the physical object be in the case that a virtual element could enhance? One possibility might be the enhance the physical brochure to provide more dynamic and easily changed information. What function will the product perform or expanding the initial conceptual model? Okay, so considering the issue in the previous topic natin, section helps the designer to produce a set of initial conceptual model ideas. So this idea must be thought through in more detail and expanded before being prototyped or tested with the user. For example, concrete suggestion of the concept to be communicated between the user and the product and how they are to be structured, related, and presented are needed. So this means deciding which function the products will perform and which the user will perform, how those functions are related and what information is required to support them. This decision will be made initially only tentatively and may be changed after prototyping and evaluation. So what function will the product perform? So understanding the task product will support its fundamental aspect of developing the two conceptual model. But it's also important to consider which element of the task will be the responsibility of the user and which be carried out by the product. For example, the travel organizer may suggest specific vacation option for a given set of people, but is that as much as it should do? Diba? Should it automatically reserve the booking or wait until it is told that this travel arrangement is suitable? So developing scenarios, essential use case, and use cases will help clarify the answer to this question. So deciding what the system will do and the user will do is sometimes called the task allocation. Example, how are the functions related to each other? Function may be related temporarily. Example, one must be performed before another, or two can be performed in a parallel. So they may also be related through a number of possible categorization. Example, all function relating to privacy on a smartphone, or all option for viewing photographs in a social networking site. The relationship between tasks may constrain user or may indicate suitable task structure within the product. For example, if one task depends on another, the order in which tasks can be completed may need to be restricted. Next, so what information is needed? Um, what data is required to perform a task? How is this data to be transformed by the system? Or data is one of the categories of requirements identified and captured through the requirements activity. During conceptual design, these requirements are considered to ensure that the model provides the information necessary to perform the task. Detailed issue of structured and display such as whether to use an analog display or digital display will more likely to be dealt with during the concrete design activity. But implication arising from the type of data to be displayed may impact the conceptual design issue. Again, for example, identifying potential vacation for a set of people using travel organizer requires the following information. So what kind of vacation is required? Available budget, prepared destination, if any. So prepared dates and duration. So how many people it is for, and any special requirements such as disability that this group has. Okay? So concrete design. A concrete design, conceptual design, sabi nga, conceptual design and concrete designs are closely related. The difference between them is rather a matter of changing emphasis. So during design, conceptual issue will sometimes be highlighted, and at the other times, concrete details will be stressed. Producing a prototype means making some concrete decisions, albeit tentatively, and since interaction design is iterative, some detail issue will come up during the conceptual design and vice versa. Designer needs to balance the range of environmental, user data, usability, and user experience requirements with functional requirements. These are sometimes in conflict. For example, the functionality of wearables interactive products will be restricted by the activities the user wishes to perform while wearing it. A computer game may need to be learnable but also challenging. There are many aspects to concrete design of interactive products. Visual appearance such as color and graphics, icon design, button design, interface layout, choice of interaction device, and so on. Concrete design also deals with issues related to user characteristic and context. Two aspects that have drawn particular attention for concrete designs are the accessibility and inclusiveness. And designing for different culture, accessibility and inclusiveness, sabi nga, yung accessibility refers to the extent to which product is accessible to as many people as possible, while inclusiveness means being fair, open, and equal to everyone. So the aim of inclusive design is to empower users in their everyday and working lives. Um, Cross-cultural design includes use appropriate language, color, icons, and image, navigation, and information. So these are all important for a concrete design. Okay, so using scenarios. Okay, again, so using scenarios are informal story about user tasks and activities. Scenarios can be used to model existing work situation, but they are more commonly used for expressing proposed or imagined situation to help in conceptual design. Often, stakeholders actively involved in producing and checking through scenarios for a product. Uh, Bodker suggests four roles as a basis for overall design. So for technical implementation, as a means of cooperation with design teams, and as a means of cooperation across professional boundaries. Example, as a basis of communication in multidisciplinary team. In any one project, scenarios may be used for any or all of these. More specifically, scenarios have been used as a script for user evaluation of prototypes, as a basis of storyboard creation. Okay, so build a shared understanding among team members. Scenarios good at selling ideas to user, managers, and potential customer. Okay, so this example to ng mga sketches. Okay, sabi nga, no need na kailangan maganda o magaling ka sa drawing. So, pwede ka nagawa ng mga symbols. Okay. Okay, so generate card prototype from a use case. So, paper prototyping as a core tool in the design of telephone user interface. You know, example. So, paper prototyping is being used by telephone and tablet companies as a core part of their design process. So, tingin natin yung sa ating figure. So, mobile device are feature-rich. They include megapixels, cameras, music player, media galleries, downloaded application, and more. So this require designing interaction that are complex, but that are clear to learn and use. Paper prototyping offers a rapid way to work through every details of the interaction design across multiple applications. So explore the user experience. As a set of a, let's see, explore user experience persona. Okay, a set of a cardboard prototypes that covers a scenario from the beginning to end may be the basis of more detailed prototype, such as an interface or screen sketch, or it may be used in conjunction with personas to explore the user end-to-end experience. This later purpose is achieved by creating visual representation of the user experience. So these representation are variably called a design map. Okay, so a design map. So in design map or a customer journey map or an experience map. So they illustrate a user path or journey through the product or service and are usually created for a particular persona, hence giving the journey sufficient context and detail to bring the discussion to life. So they support designer in considering the user overall experience when achieving a particular goal and are used to explore and question the design experience and to identify issues that have not been considered so far. So they may be used to analyze existing products and to collate design issue or as a part of the design process. There are many different types of representation of varying complexities. So two main are the wheel and the timeline. So experience the map drawn as a wheel. So the wheel representation is used when interaction phase is more important than interaction point. So the timelines is used where service is being provided that has a recognizable beginning and endpoint, such as purchasing an item through a website. Okay, so example, a timeline presentation in our figure. So it illustrates the structure of timeline and how different kinds of issue may be captured. Example, question, comments, and ideas. So experience map drawn as a timeline. A design map or customer journey map or experience map, they illustrate user path or journey through the product or service and usually created for a particular persona and based on particular scenarios, and giving the journey sufficient context and detail to bring discussion to life. So construction of physical computing. Construction as a prototyping and building alternative progresses development will focus more on putting together components and developing the final product. So this may take the form of physical products such as set of alarms, sensors and lights, or a piece of software or both. Whatever the final form, it's very unlikely that you will develop anything from the scratch, as there are many useful um, resources to support the development. So we introduce two kinds of resource, the physical computing kits and the software development kits. So physical computing is concerned with how to build and code prototypes and device using um, um, device using electronics. Specifically, it is the activity of creating physical artifacts and giving them behavior through a combination of building with physical materials, computer programming, and circuit building. Typically, it involves designing things using a printed circuit board, sensor, example, infrared temperature, accelerometers. So this used to detect the state, and actuators, yung mga motors, yung mga valves that cause some effects. Ayan. So physical computing kits. So the Arduino board. Okay, so one of the earliest Arduino, the aim was to enable an artist and designer to learn how to make code and physical prototypes using electronics in a couple of days, having attended a workshop. So the toolkit is composed of two parts. Uh, the Arduino board, which is the piece of hardware that is used to build objects, and the Arduino IDE, o yung Integrated Development Environment, which is a piece of software that makes it easy to program and upload sketch. Physical computing. Okay, so the Makey. Okay, the Makey toolkit. Okay, so the Makey toolkit comprised of printed circuit board with Arduino microcontroller, alligator clips, and a USB cable. It communicates with the computer to send key presses, mouse clicks, and mouse movements. There are 6 inputs: the 4 arrow keys, the space bar, and the mouse click. Positioned on the front of the board, the alligator clips are clipped onto the order to connect with the computer via the USB cable. The other ends of the clips can be attached to any non-insulating object such as vegetable or piece of fruit. So thus, instead of using computer keyboard's button to interact with the computer, external objects such as bananas are used. So the computer thinks Makey is just like a keyboard or mouse. Ayan, example. Yung Makey natin. Okay, so they run a series of workshops where small groups of retired friends aged between early 60s and late 80s. Assemble and play with the Makey Makey toolkit. So after playing music using fruits and vegetables as input, they saw many new possibilities for innovative design. Making and playing together, however, childlike it may seem at the first, can be catalyst for imagining, pre-thinking, and exploring. So the construction of SDK. So, a software development kit or yung SDK natin is a package of programming tools and components that support the development of application for a specific platform. Example for iOS on iPad, iPhone, and iPad Touch for the Kinect device and for the Windows Phone. Typically, an SDK includes an IDE or yung Integrated Development Environment, documentation, drivers, and sample programming code to illustrate how to use SDK component. Some also include icons and buttons that can easily be incorporated into the design. While it's possible to develop application without using SDK, it's, it is so much easier using powerful resource and so much more can be achieved. For example, the availability of the Microsoft Kinect SDK makes the device powerful gesture recognition and body motion tracking capabilities accessible. This has led to the exploration of, for example, motion tracking in immersive gaming. It's also user identification using body lens, robot control. Okay, so yung mga uses ng SDK na. An SDK will include a set of application programming interface in API natin, API, that allow controls of the components without knowing the intricacies or how they work. In some cases, access to API alone is sufficient to allow significant work to be undertaken. Okay, summary. So different kinds of prototyping are used for different purpose and different stage. And prototypes answer question. The final product must be engineered appropriately to aspect of design natin, conceptual and concrete. To generate conceptual design, consider interface, metaphor, interaction, types, and interface types. Storyboard can be generated from scenarios. Card-based prototypes can be generated from a use case. And physical computing kits and SDK facilitate transition from design to construction. Okay, so that's it. And thank you.